So good morning, right? Presentation, okay, right? So give it presentation, right? Uh, okay. So today we discuss about distance from point to plane. Distance from point to plane. Okay. So given point with positional vector a bar, right? So given point with position vector a bar, okay, and given plane. So plane, that is r bar dot n cap equal to d. Now we have to find the distance from this point to this plane. Okay, so this point to this plane. Now so distance, this point is P. Okay, distance from P to the plane. We call it some phi 1. So plane is phi 1, right? This we have to find. Okay, right. Okay, right. So now this is the space, x-axis, okay, z-axis, this is y-axis, okay, sorry, this is y-axis, okay, right. Right, so this is y-axis, okay, right. This plane is, now we draw this plane. Where is this plane? See, from this we can understood that n cap, this is r bar dot n cap is there, d equal to a perpendicular distance from horizon to plane. So now we can, this is the plane, right? So this is plane. So this is phi 1 plane. So plane 1, this equation is r bar dot n cap equal to d. So from this the meaning is, so okay, this d is the distance, okay, right. So this is the d, okay, distance from horizon to plane, right. Now we call this point also foot of the perpendicular. This is the perpendicular, right? The foot of the perpendicular is m, right? Foot of the perpendicular is m. So ON equal to, here ON equal to d, right? So the given point, where is given point? See, now we can, this is the given point. This is P with positional vector a bar, right. Now we consider another plane through this point and parallel to first plane. So now we consider another plane, right? This is the plane, okay, right. Okay, this point is P, okay. So now we have to find from this point to this plane distance. So right, this point is some Q, we call it Q. Now join this distance we have to find. Now we have to find PQ equal to what? This we have to find, right? Okay. Now see, on this also some distance we call n bar. See, from this what we PQ equal to n bar, n bar, this distance PQ equal to n bar. Okay, no problem. Now see, now we write the equation of, see, equation of phi 2 we can write phi 2 as, because this phi 2 is passing through the A bar, okay, passing through the A bar, and this phi 2, this second plane is perpendicular to the n cap, because this first plane is perpendicular, this is the perpendicular unit vector, normal unit vector, okay. So that means n cap is perpendicular to the first plane. Since the second plane is parallel to first plane, n cap is also perpendicular to the second plane, okay. So we can write n cap equal to, okay, 0. This is the equation of second plane, okay, right. So for what purpose this? See, listen here, no problem. R bar dot n cap minus A bar dot n cap equal to D, okay, right, 0. So R bar dot n cap equal to A bar dot n cap. See, what is this value? This represent what? So R bar dot n cap equal to something. So this is the perpendicular distance from horizon to second plane. See, this is the perpendicular distance. So A bar dot n cap is perpendicular distance from horizon to second plane, right. So horizon to second plane, okay, right. So horizon to second plane is that is ON bar, ON bar is A bar dot n cap, okay. ON bar is, right. What we required? PQ. We required PQ. That PQ is NN bar. That NN bar is ON minus ON bar. Okay. ON is D. See, ON is D. Right. Minus. Okay. This is a distance modulus. Okay. Or magnitude. ON minus ON bar. ON bar is now A bar dot n cap. Okay. Now this distance can be written as, okay, right, A bar dot n cap minus D. Because the distance we can change one minus, so minus also will go, okay, because determinant, this is magnitude, by A n cap. In place of n cap we can write finally A bar dot n bar by magnitude of n bar minus D, okay. So minus D, because this is completely, okay, right. So finally this is the distance from, okay, distance from a point, this point to plane. See here, distance from this point to plane is, this is the point, this is the plane. So finally we can write distance is equal to, see, in place of R bar you substitute A bar dot, okay, A bar dot. So n cap minus D by, no need to write by here, because n cap is unit vector. Suppose n bar is given, then we can write A bar dot n bar minus D by magnitude of n bar. This is the distance from point to plane, okay, right. Okay, right. Cartesian form, okay, by magnitude of right. So this is the distance. Okay, this is the distance, right? Right. Suppose this equation is given like this, the distance from, okay, distance from A bar. So whenever this equation is given, so distance equal to A bar dot n cap minus d. Okay. But here d is not a perpendicular distance. D is not a perpendicular distance. Right. Next, suppose plane equation ax plus by plus cz equal to d. This plane is given and a point x1, y1, z1. Okay. So from this point to this plane, that distance is ax1, by1, cz1 minus d by, so a square plus b square plus c square. Right. So distance. Next, exercise problems. The exercise ఎక్కువగా ఓకేనా, చూద్దాం. బ్లాక్ ఇదేంటిది? Right. Okay. So first problem is first problem, right? Z equal to 2. This is the equation of plane. So in each of the following cases, determine the direction cosines of normal to the plane and distance from horizon to the plane. So direction cosines, here we have to find direction cosines of the plane. This is the equation of plane. Okay, direction cosines of the plane. Direction cosines of the plane and distance from horizon to plane. Distance from horizon to plane. So these we have to find in this. Okay na? Matlade the equation of a plane. How? See, 0 into x, this can be written as z equal to 2 can be written as 0 into x, 0 into y plus 1 into z equal to 2. This is the equation of plane. Okay. So equation of plane. From this we conclude that direction cosines of the plane. Okay, direction cosines, not direction cosines of normal to plane, not direction cosines of normal to plane. This we have to find. Okay, see here ax by plus cz, ax plus by plus cz equal to some constant. Therefore here a b c, a equal to 0, b equal to 0, c equal to 1. These are direction ratios. And also direction cosines, because this square plus this square plus this square equal to 1. Okay. So here these are not direction ratios. These are direction cosines. So direction cosines are, okay, 0, 0, 1. Okay, 0, 0, 1. These are the direction cosines. Okay. Next, distance we have to find. Distance from origin to this plane. Distance from origin to plane. Distance equal to, okay, origin is 0, 0, 0, right? So this plane equation is this, magnitude of, okay, 0 into x, already 0 into 0 is there. So again in place of x substitute 0. So 0 into 0 plus 0 into 0 plus, okay, 1 into 0 minus 2 by magnitude of a square 0 square, b square 0 square, 1 square, okay, this equal to minus 2 by, okay, 1. Minus 2 is there, this minus 2, okay, minus 2 by 1. So this is 2 units. Distance is 2 units. Okay, na? 2 units. Next, second problem. Suppose if we take, okay, x plus y plus z. X plus y plus z equal to 1. X plus y plus z equal to 1. Right. In this case also direction cosines. 1, 1, 1. These are not direction cosine. These are direction ratios. See, direction ratios of normal. Direction ratios of normal. These are the normal direction ratios. Okay. So now direction ratios of normal to plane are 1, 1, 1. Why these are direction ratios? Why not these are direction cosines? Because 1 square plus 1 square plus 1 square is not equal to 1. So these are direction ratios. Direction ratios. So we have to find direction cosines. So direction cosines we required. So direction cosines are, okay, 1 by root of 1 square plus 1 square plus 1 square, again 1 by root of 1 square plus 1 square plus, again same, okay, once, right. Then these direction cosines are 1 by root 3, 1 by root 3, 1 by root 3. These are the direction cosines. Next, distance d from origin to this plane. Origin to this plane. So that distance is, in place of x put 0, in place of y 0, in place of z also 0, minus 1 by root of x coefficient 1, okay, 1 square, y coefficient 1, 1 square, this 1 square. Now this is minus 1 by, okay, root 3. Now the distance is 1 by root 3 units. Okay, right. The standard form of a plane is ax plus by plus cz, okay na, is equal to some d, where what is ABC? ABC are direction ratios of normal to plane. Adi manaku ikkada. So kabatti x coefficient, y coefficient, z coefficient are the direction ratios of normal. Okay, since these are direction ratios, we can find direction cosines. How to find direction cosines? If direction ratios ABC are given, direction cosines are L is equal to A by root of, okay, like this, B by root of this, and C by root of this. Okay, by using that we can find. Okay na? Right, thank you.